So here's our lesson 2 of our mini course, on ChatGPT, large language models. In the first video of this mini course, I shocked everybody, even my colleagues, by starting out with severe flaws that ChatGPT and all large language models have. I was told that, maybe you don't start with that because we're actually created a product around AI. So we need to speak about the positives. And look, for me, we're after the truth. What I want to show you is how these models can help you, but I don't want you to worship them. I need you to understand the weaknesses of the models and the strengths of the models, okay? And we're going to go over that. We're going to go over strengths in the next lesson. So the first lesson was some weaknesses. The second lesson today is just on some theory about how they work. And the next lesson will be about the strengths. And then I'll see you on September 28th at noon. You can sign up on this page. It's a free unveiling of our 401k AI 2.0, advisor AI 2.0, and we're going to teach you some stuff on that live session, live stream. So, foundation of these large language models. When you go into ChatGPT, I mean, many people experience this, it is very human-like in the way it interacts. I know that after you use these tools for a while, you realize that they're not really as human-like as it seems. But because when you start out, the expectation is so low, you're used to computers not having the ability to construct natural language in such a way, it shocks people because it's a question of low expectations, right? And then people think, oh, it's like human, but it is not, okay? Large language models are fundamentally different from humans. This makes them actually very, very effective for some tasks. Like I will show you on September 28th that if you use these models for summarizing, reading, parsing, analyzing documents like PDF documents, client statements, somebody gave you their individual 401k statement, or it's a retirement plan that gave you their 408 B2 form. You need to read it and analyze it quickly. You cannot do without these models. I mean, if you don't use them, you will be stuck working for so much longer. Your competitors will do a better job. Okay, so these models can do that. But in the first video, I showed you that they cannot do some of the basic math, right? They cannot do sorting. They cannot sort numbers, which is actually pretty astounding. So there are some things where there are gaps in these models and you need to use them properly. And most other firms, I think now they're putting out some AI product that typically writes some social media posts and maybe some emails. And I think that is not the most important use, right? Basically, this is a very sophisticated autocomplete use. The most important use is about asking questions about data sets. For example, like I said, PDF statements and so on. But in order to use this model properly, I think you really need to understand how it works. And I'm going to show you a couple of slides. So the first slide is very core, very basic to all of the large language models. This is a vector math with words. And when I saw this, probably around 2015, I almost fell off my chair because this is so amazing. You can actually think of language as math. And math is not accounting, right? Math is not boring. Math is exciting. It's one of the most beautiful, poetic things in the world. In my mind, math is really the language of God that God allowed us to understand in order to actually, understand this world and build things in it, because everything has math around us. But for the longest time, people thought that math and language, they thought of them as kind of almost opposite. Like language is something flowery, something beautiful, and math, something very strict, your mathematical logic. But in reality, this is not so. Mathematics and language are very, very interrelated. In fact, you can think of language as an elaborate mathematical model. And this does not make language more down to earth. It does not make it less exciting. I think, in fact, it's quite the opposite, right? That this understanding will enrich you as you go forward. So looking at this slide, basically what this researcher did, and this was Mikolov, a Bulgarian computer scientist who did this in Google, I think, in 2013 or 2014, I don't remember. What he realized was that you can take the word vectors, you can calculate vectors in a certain way, and I'll explain how they're calculated. For every word can be described as a vector, right? Series of numbers, not arbitrarily. If you do it in a certain way, you can come up with vectors for every word. And the way you do it, essentially, for all you finance, I mean, we're all financial professionals on this call mostly, right? So, or hopefully everybody, you're as financial advisor, you know what correlation is, for example. You always study interrelationships of financial assets. Well, this is really a very glorified correlation of words. I know it's probably oversimplifying it to a large degree, but in the end, you can calculate correlations of words. If the word king and the word queen are meet each other in certain contexts, then they give a certain number of vectors that are highly correlated. It's related to a cosine function in math. And that's all well and good, right? Words can be thought of as correlated assets, but what comes next is amazing. You can actually do math with them. For example, you can take the word king and you can subtract the word queen. You see there's two vectors, and you can take the word man and subtract the word woman, right? We know there's only like men and women out there. So when you subtract these things, you get a different two vectors, and it's not obvious why they should be the same, right? When you think of math, it's not quite obvious. But in language, it's obvious that if you think about it, that, okay, the difference between the king and the queen is about the same as the man and the woman, right? Because king and the queen, at the core, they're man and the woman with some regal status. But regal status is more or less the same for them, so it cancels out in math. And what's left is a difference between the man and the woman. And sure enough, the difference between these vectors in the proper language model turns out to be the same. This is an amazing observation. I want to say, this is the core. On this observation, many things are built upon, right? So, and it works for some other things too. It works for other words. For example, distance between a country and its capital is going to be roughly the same. So difference between USA, Washington, Russia and Moscow, Japan and Tokyo, Turkey and Ankara will be about the same, roughly, okay? Also, there are synonyms that will be very similar, like geographical concepts like village, town, country, city will be roughly close. Oil, gas, petroleum, sad, happy, joyful. Now, there's a problem right there, right? You can see that sad and happy and joyful are not really synonyms. They're similar in some sense, but they're antonyms. And so this is a foundation, but it's not the end. But you really need to think about this model, a large language model, first as a correlation set of words, right? That's a simplified way of thinking about it. Then you add many more layers of complexity, right? One linguist said that you shall know a word by the company it keeps. And so the word is not a word. A word is not a word. The word in a certain sentence, like back, I have pain in the back. That's a completely different meaning from I will come back, or have you closed the back door. They may be related sometimes, but they're different meanings. So there's elaborate math going on to create a word vector for every word. And then there was another innovation called transformers. Transformers underpins a lot of the language modeling right now. I mean, all of it. What the observation with transformer research team was pretty amazing. They realized that you can actually create different vectors in some sense for a word in each sentence. So in each sentence, a word changes the meaning depending on the sentence, right? And it does that through a certain kind of key and query mechanism, which we're not going to cover. I'll discuss it a little bit on September 28th. By the way, don't forget to sign up for the live session on September 28th. So what you've seen is the way these models work. Now think about what ChatGPT does. Many of you have looked at ChatGPT chat, and you saw that it generates kind of word by word. So it goes a word, and then there's like a blinking cursor, and then there's a word. Some people think that that's just like a cute animation, maybe a retro animation, or just something to add some kind of element of interaction. But that is not so. That is actually the way the model works. What it does is that at every stop, every word, it will create a simulation. Again, financial advisors should know what a Monte Carlo simulation is. Roughly, you can think of it as analogous to this. A model will simulate all these words or create a probability distribution for words, and then we'll pick the next word. Sometimes it will pick the most likely word, sometimes a little bit less likely, but it's still going to be out of the set of words that are most likely. So, for example, if somebody writes, I love to eat, right? What would be the likely next word? No, I mean, it's not going to be sky. It's typically not going to be grass unless you're a cow, or, depending on maybe wheatgrass or something like that. It's going to be like pizza or steak or milk or veggies, whatever. So there's only a limited number of words that are very probable after the words I love to eat. And that's exactly what happens. The model will use those word vectors the correlations, remember, and we'll say, based on these correlations, what is the next most likely word? So it outputs word by word by word by word. And so this way, a large model can very effectively mimic human language. I mean, they're very effective now, scary good at it sometimes. It can also very effectively, as we'll see on September 28th, it can very effectively summarize your client statements. You give it a PDF with 40 pages, it will give you and say, give me a list of funds with weights. It will output a table. It's able to summarize that because it knows that part of language very, very well. From that, you can also see why in lesson 1, I told you that it cannot sort large lists. It cannot do division by more than one digit. Why? Because if you remember your school division, when you do division by multiple digits with a pen or a pencil, this is actually a multi-step process. This is a multi-step process that is not a simple, here's the next probable step. There's actually, it's a non-linear process of thinking, if you will. Sorting is the same way, right? It's a process where you need to keep many, many steps in your head. Whereas this model, even though it tries to, these transformer algorithms, they allow these models to keep much more context, they call it. But it's still not good enough to sort a list of 50 numbers. I just showed you that it is not. So this is important to understand as you use these models, as you use them to win over business, to become, more successful, you need to understand their limitations. And one last thing is, from this, you can also understand there's a parameter in ChatGPT and all these models that's called temperature. Maybe you've seen it. It's called temperature parameter. Well, a temperature really comes from physics. It just means degree of randomness. In other words, if you set temperature to 0, and you can go into ChatGPT chat and you set temperature to 0, you're going to see that it will always output the same thing. In the next step, when it infers the next word, it will always pick the most probable word, the most likely word, always. It's just going to do that as a clock. Now, if you're not going to do that, if you're going to set temperature to, let's say, 0.5 or 1, it's going to pick a likely word, but not the most likely word. So it's going to sound less robotic and so on and so forth. So when you want to be as accurate as possible, you want to set temperature very low. If you want more creativity, you set it high. Okay. And in the next lesson, I'm going to talk to you about privacy. I think this is it's understood, but it's not completely understood how dangerous ChatGPT is for privacy. This is why we at Extreme on September 28th, we're unveiling our own model that is strictly gated, that sits on a server, that is protected, that each client's data is siloed, and it goes nowhere else, right? When you use ChatGPT, of course, your data now belongs to ChatGPT, to OpenAI, which is not so open anymore, and also it belongs essentially to the world. So next lesson, I'm going to talk about privacy issues, how you can mitigate them, how to build your own model, which we did at Extrema. And as you'll see on September 28th, it's actually not inferior to ChatGPT. It is far superior for your particular uses, for financial advisors, for finance investments. It is far superior because it can do so many more things than ChatGPT to make your job easier. Okay, so I will see you on September 28th. Thanks for looking at our lessons. Lesson 3 on privacy will be below. Bye.